Hey guys, welcome back. So today on this episode, we're going to be talking about track. So we're going to have our first level track down, how I mounted it, how I wired it, which was a little bit different than I wired it on the previous layout. So I made a little improvement there. And we're going to show you the wiring underneath the layout. We have all the main blocks in place. We have all the power supplies in place, the TIU, the TMCC base. We've got pretty much all the main wiring ready to go over to the blocks, and the first two loops finished, and then we'll be starting on the upper level, but it's all ready to go where I just have to run the feeds down to the block underneath the layout and I'm finished. So I've got everything sort of ready to go and wired up. We got our switch controls and our little control panel. So we got lots of stuff to talk about today. Lots of stuff to go over, and we'll do our first test run on the loop. So let's jump into it. So we start to lay out our track, and we are using a combination of a track by USA Track, which is excellent track, and we have some MTH Lionel track that was sort of left over. We got a whole box of it, so we're going to be using some of that too, combination together. And they all line up, they're all the same height and everything like that, so no problem there. But a couple of things about USA Track and MTH Track. So if you're not familiar, just so you know before you buy either one ahead of time. So first of all, the USA Track is you can get in different numbers of ties. I like, if you look at the ties going down here, they're really nice. I like the way it has sort of more extra ties in it. Just makes it look a lot nicer than the MTH stuff. So on these straight pieces that I'm going to be using, I'm just going to add two more ties into here. I'll just slide these down and add two more ties so it matches sort of the USA Track, which if you look over here, I've already kind of done. So right here, I think right here. This one right here is actually a piece of Lionel track, MTH Lionel track, but you can see I added two more ties so it all sort of matches the rest of the track. So you can always add ties, and we're going to show you how to do that and the tool to use to make it a little bit easier if you want to do it sort of the right way when you're doing your extra ties. But a couple things about the USA Track. So if you look at the track right here, actually, for instance, you can see right now these are 72s, and you can see when it's going around the curve here, it sort of lifts off. It sort of bows in, right? So the way Kurt makes these is they're sort of bent in a way that once you put your screws in, it'll give you the true radius that you're after. So my point here is that if you're going to be using track for, say, the on the floor layout, temporary Christmas layout, stuff like that, if you don't have a place to screw it down, like a piece of plywood or something, and it's just laying on the floor, this is probably not the track you want to buy because it's going to flex like this around these curves. I think 42 is even worse than this. This is 72, and you can see. So this is great track, you just need to screw it down to get the true radius, and that's the way he bends it, so that once it's all screwed down, you're not screwing up the radius and it's not changing on you. So really nice, but keep that in mind if you're going to buy track for just on the floor. If you're doing an on the floor track, I would suggest MTH's standard gauge Real Tracks, which is great stuff. Here's a piece of MTH Real Tracks. You can see it has the plastic road bed. It has the snap together ends right here. So it's just kind of like Fast Track, and also the O-Gauge Real Tracks where it just snaps together. But it lays completely flat, right? And it's great for on the floor or around the Christmas tree layouts. And just in case you're worried, MTH is making this track. It is not discontinued, as opposed to what a lot of people think. So it's actually due in pretty soon. I was over at Just Trains, and he told me it's probably going to be end of this month, so probably next month. Everything's probably delayed because of shipping, but they are actually making it. Mike's making the track again. He's going to make the switches that go with the tubular too and everything. So all this is going to be available also. So, but I have a whole bunch of this for just around the Christmas tree and stuff like that, and it works really well. So that's what you want to use if you're doing a temporary on the floor and you cannot screw it down. Now, if you can screw it down, then of course you can use the USA track. You could also use the MTH track, but even the MTH track is not, the tubular is not good for on the floor because it tends to come apart at the joints. It's not as tight as the USA. So that's something to keep in mind. So if you're going to do on the floor, I would really recommend the real tracks. Now, the one thing about the USA track when you get it is that you're going to find it's very oily, not on just the rails, but on the ties here. There's going to be it's almost like grease. So they're kind of, they're a little bit greasy when you get them. Kurt has a note in the box that explains why they're like that, to keep them obviously from rusting and things like that. The thing about it is I don't want grease and oil on my rails because I'm using the DCS system, and that is one thing you don't want. Now, it's great for conventional, so that's fine. And if you're just running conventional engines, you probably don't need to do anything. But for us TMCC and DCS command systems, you don't want a whole bunch of oil and junk on your track because that's going to, degrade the signal. So just keep that in mind. These will need cleaning. I think I spent a good hour and a half cleaning all the tracks before I started assembling them. I don't know if you can see it in the camera, you probably can't, but you can see if you look at the ties and stuff like that, it looks like it has grease and gunk on it and stuff like that. So, but just touching it with my hands, I'm getting like sort of oil all over my hands and stuff like that. So keep that in mind, you have to clean it. So what I did is I actually used something really simple, easy way to clean these. So all I did was I took some Windex, put it on a rag, and I just took the rag here, and all I did was I run it in between the rails real quick and on the outside of the rails to get the edges of the ties. And it cleans it up like pretty quickly, super nice, right? And then I'll take a little Q-tip if there's any big gunks within the joints here inside the groove right here. I didn't worry about the bottom, nobody's gonna see that, right? But that's how I clean them up really quickly. And they cleaned up really nice. You don't wanna use paper towels or anything because it's gonna rip up really easy, snag on it. So you wanna get some kind of this is a microfiber rag, just I'm using right here. And that'll clean them up really nice, okay? And then you'll be good. But you will have to spend some time cleaning them, just FYI. All right, the next thing about the USA track that's nice about them is they use these, I'm not sure what the material is. It's some kind of a fiber insulator, but they're really tough, really nice, that they won't short out and stuff like that. And they're really tight. Like the rails, the ties on here are super tight on here. So that makes a difference on how you join these because in the instructions it says that the pins are just a little bit bigger than normal track pins that you would get in the, say, the Lionel MTH ones, which is really nice because these fit together super, super tight, which is another thing I want for the DCS command signals, right? And he has some suggestions on how you do it with a wood block and like a little small hammer. I instead use this. This is a trusted tool I use in all my O-gauge stuff. This is a rubber, hard rubber, and a plastic hammer, right? And these won't damage the ends of the rails when you bang on them, but they're hard enough that they will pound the rails in. And so the way you work it is basically you put these together right here and you tap them in. You do not want to try to work them in like this. First of all, your hand's probably going to slip and you're going to cut it because this is so tight. But you want to basically just tap it in, and these rails, when you tap them in, will come together and be super tight. So that's one of the nice things about the USA track system. The other thing that is, if you want to pull the pins out of any of them, you do not want to try to just yank them out or wiggle them out. You want to tap them in a little bit so it goes past the dimple, and then they'll pop right out. So another nice feature. If you're ordering USA track, I would actually get some extra pins. I wish I had some extra pins, because if you are going to join it with any other track system, or in this case I have some switches I'm putting it on, I would have rather used the thicker pins just because they're nice and tight. So yes, USA Track, highly recommended. It's the same height and everything as standard Lionel MTH track, so if you have some of that, you can join them together, no problem. And just a couple of quick tips about the USA Track that you have to keep in mind. And then for the MTH track, I have a whole box of this that I don't want to waste, so I am going to use these 14-inch straights here, but they're only 4 ties, right? So what I did is, because these are actually a lot looser than the USA, I'm just moving them down like sort of like that, and then I'm putting an extra tie here and at the other end here to make it match the USA Track. So you get that sort of really nice tie look as it's going down the platform, right? You get that nice, it just, the more ties just makes it look really nice. So I will say that's one thing I do like about that. Now, when you order your track from USA Track, you can order different amounts of ties within your track. So keep that in mind when you're ordering it, because you have different choices. But because I already had this track, I am just going to add ties to this track because I have plenty of this straight stuff. And I'm just going to take the ties off and put them on to make extra pieces. So let me show you how I'm adding extra ties to this track. We have our track here, and all we do is we basically take the existing rails that are on here and we just sort of slide them down. You just sort of wiggle them, because again, they're not as tight as USA Tracks is. You wiggle them down, and then you sort of space them out evenly, right? And then we're going to add 2 more inside here. So obviously you've got to use a piece of donor track, right, that you're going to pull your ties off of. So you get your tie, right? So what I do is I just, to make it easier, I just straighten out the tabs on the tie, right, so I can get it on really easy. So I'll do that on the 2 pieces I'm adding here. Okay, so now I have them all set. Then I'm going to take my little insulator, right, and I'm going to put it on the center rail right here. Just make sure it wraps around. And I'm going to get my tie and put it on. It's going to sit right in because I have the tabs up, right? And you're just going to make sure everything's lined up there. And then what you're going to do is you're going to take this special tool. So I purchased this special tool. If you are working on tubular track, standard gauge or O gauge, and you're working with ties, because you know you have to cut track sometimes, it's too long or whatever, you're moving ties around, the only right way to put them back is to use a tool like this. So this is a block and basically the track pinching or clamping tool, right? And so basically, let me show you how this works. First thing I do is I get my tie where I want it. I center my little insulator, and then I do take a screwdriver to just start it and get the tabs pushed down on all the rails, right? We do that first just to get them close to where they're going to be. And once they're pushed down, then I, make sure everything's still centered. Everything's kind of where I want it, because this is going to make it super tight on the rails once you do this. Then you're going to take your block and you put it underneath your track. So I'm just going to put it right under. It fits perfectly within the tie. And then you take your little tool right here and a hammer. And all you're going to do is push it over the rail onto the top of the tabs, and you just tap it until it goes all the way down, right? And then that'll make it nice and tight against the rails. And obviously you're going to do that for all 3 of them. But this block underneath is obviously what's making it stay solid, right? And so now I have my rail on here, and it's super tight. And that's it. And that's how I'm going to add some extra ties to these ones that from MTH Lionel that don't have it, and then I'll just move them, space them so it's even across everything, and I'll get the same look as I have with the USA Track. Now, USA Track does sell extra ties. You can buy them by the bag too if you want to buy some extra ones instead of getting them off donor tracks like I'm doing right here. But you could do that too. They're pretty cheap. I forget what they were. I forget what he told me they were, but they're pretty cheap. And you can get some extra ties too with insulators and everything when you're ordering your USA Track. So if you do have to cut a piece or something and you want to move some ties around or whatever, then you'll be able to do that too. But that's just a couple of quick hints for assembling the track, and then adding things like ties and everything. This little tool is really worth the money. It wasn't that expensive, I forget, maybe 25 bucks or something, but it's just two pieces of aluminum basically. You could probably make it yourself if you wanted to, but I just quickly picked this up, and I got it at a train show, I think, and yeah, it's definitely worth it because it makes it so easy to put this back down. If you just try to use a screwdriver to put your tabs back down, they're never going to be tight enough, right? And the ties are always going to move around. Or if you screw down the tie, the rail is going to move within the tie. So you want to do it the right way if possible. And there's the finished product. There's the 6 tie 14-inch against the original 4 tie, and you can see, you know, I think they look much better with the extra ties personally. So, and that'll be all I need to do to add these to my layout here. Now, I won't have to use too many of these actually, so, but this is fine. It works fine as long as the insulators are okay, which I check before I put them in there and everything. Then we'll be fine. Yeah, that's it. So just remember all these little tips if you're assembling this standard gauge track using these 2 different vendors, either the USA Track or the Lionel MTH Track. So the other thing we want to give you a little quick tip on are the Lionel MTH 72, or what they called wide radius switches. So these actually have a weird issue, which I don't understand the logic behind this, but basically if you look at the end of this track here, right, or switch I should say, you can see the end here, right, is all even right across here. The same thing over here. But if you look at this is actually recessed back right here. You wouldn't be able to actually put the track up against this rail right here as it stands, right? You couldn't put it up because it's actually recessed back from the base, which doesn't make any sense. I think, you know, Kirk from USA was telling me Mike was trying to keep this at whatever it is, the 14-inch length or whatever, but this is weird, right? Because you actually have to modify the piece of track coming in on this one lead right here, right? So what I had to do is, if you look down below here, I actually had to cut out the bottom part of the rail. Like I had to cut it sort of in half. I, you know, basically took a little Dremel and just chopped it off so that this could slide up to this portion right here, right? Otherwise, I couldn't get it even anywhere close to where it should be. So just keep that in mind. Now, I've had the 42 radius ones, and those don't have that same issue, but these wide radius ones do. And it took me by surprise, obviously, when I saw that. So you will have to modify the track rail just a little bit so it can clear and get up and join up with this this rail that's here. This rail should either just be coming out a little more, or I don't know. I don't know what he was doing here, and I don't know what the solution for that one is, but for whatever reason, that's the way they made them, and you will have to do a slight modification right here on this one rail only, and then everything will hook up correctly. Hey guys, okay, so we've got some basic track laid down. We're getting together our, you know, playing with our track plan here, and I put a couple of the bigger items, the roundhouse, powerhouse, the illuminated terrace, because those are the big giant items, to fit things and, you know, position them correctly on the track. So for instance, I'm using my Hiawatha cars here to go around the roundhouse just to make sure everything clears, right? Because these are the longest standard gauge cars ever made. And so if these clear, pretty much everything else clears. So, so yeah, we're checking all this stuff out and just testing everything. But I thought I'd show you a couple of quick tips of what I'm doing as far as the connections to the track. So I'm changing what I did before from using the lock-ons to a different method, and which will be a little more secure. Actually, the lock-ons were some of my cause of my issues last time, where the track would lose power, and it turned out it was because of the posts on the lock-on were actually sort of broken from their connector tab. So you couldn't see it, but because they're just a crimp connection, when I was tightening them up, it actually broke the connection a little bit. And you know, trains would move up and down the track, and then it would break the connection and then reestablish it. So it was kind of a pain, and I just discovered it by accident. But so I'm eliminating those lock-ons, and I'm using a different method, which I'll show you in a second. But first, we're going to show you the roundhouse and how to mount the track in there. I've seen a couple of posts on different forums about confusion on how it actually works, so we'll show you how it actually works. Mount the track inside the 444 Lionel roundhouse. There's no extra brackets or anything that come with the roundhouse. So I've seen a lot of posts about missing brackets. I must be missing a bracket or something. No. And there was some confusion on kind of how it works. So there's two anchor points basically for the track as it goes into the roundhouse. So first we have this front anchor point, which basically just has these two little levers right here, which move back and forth, and all they do is they pinch, as you can see, the edge of the outside rail, and that's what holds it down. And it's really tight once you pinch it down. So the height of the tie is exactly right for the height of the rail, and the rail stays just a hair above this frame right here, and then you just use these and you just turn them until they basically stop against the little bump that's sticking up there, and then they're tight. So that's all it is for the front. Okay, the confusion has always been in the back here, so let's go look at the back. In the back, basically, where you see sort of those four cutouts of the foam here, or I should say the felt. Let me zoom in right here so you can see it really closely. But basically the roundhouse comes out with these sort of punch outs in the bottom of the roundhouse, and they're just two tabs that stick up, one set in each direction. And a lot of people were like, well, it doesn't line up with the ties and everything, but it actually does line up with the ties if you just move your ties, and that's the key to the whole thing. So you have to actually move the ties on the track, because it doesn't know like what straights you're using, if you're using half straights, full straights, how many ties are on your straights. So basically it's just meant so that you can move the ties, and then all you do is basically one edge of the tie gets trapped underneath a tab, right? So you can see on mine right here, all I did is I moved this tie back, and if I really zoom in here, hopefully you can see it, but the basically the little edge of the tie that sort of flips up is right underneath there, and it's a tight fit. So it just hooks underneath there, and that's what holds it in. And that is super tight back there. Now, I additionally added this little felt bed underneath it just to prevent scratching the track from scratching the bottom of the roundhouse, right? To keep the paint finish pristine. So you could use either set of tabs. You could use the front one or the back one. I used the back one, so basically all I did is when I put the track inside, I sort of like went in like this, right? I lifted up the back, I put it underneath the tab, I laid it down, right? And then I just did the little tabs right here to fasten it down in the front. And that's all the way it works. So you really, all you do is you move your ties, and that's kind of how it works. Now they are wide, if you look in the back here, right? If you looked in the back there where those tabs are, right? The tabs almost look like they're sort of too wide for the ties, but they're actually not, right? If you center your tie in between the two, they're not they're not too wide, right? So that's just the way they were made back then, and so it handles multiple types of standard gauge track. But you just pick one set of the tabs, and then you just slide your tie underneath one of those, and that's it. That holds the back in. So no screws or anything like that, and you don't have to damage the back. Otherwise, if you don't do that, the track on the inside, once you get by the front, would be flopping around, and that's not something you'd want to do. So anyway, that's how the track gets mounted in the number 444 Lionel Roundhouse. My new method that I'm going to use to power my track here is actually, as you can see right there, is to push connectors, flat spade connectors, between the slot on the bottom of the rails. So I'm just using these spade connectors right here, and all you do is you basically push them in the slot right here in the rail, right? Just push it in between. It's super tight because these are pinched basically closed, right? And you're jamming something in there, so it creates a super tight connection. And then obviously I'm gonna crimp a wire right onto that connector, and then once I do that, it just goes straight down through the layout, right? So I'll just drill a hole right underneath each one of those into the layout, and then it just goes straight down. So you don't see it. There's no solder joints to break or disconnect, and it's a really solid connection, because once you put it in there, you can't even move this thing. It's so hard, right? Because there's so much tension on it from the rail itself. And that's going to be my new method to put in my connections for the track, which will make it completely invisible basically, and then also at the same time solid, so I don't have to worry about bad connections happening and things like that. So I'm going to just take a spade connector here. I got a pliers. You're not going to be able to put it into your hand because it's just too tight. And I'm just going to basically push it in. And you can see the rail sort of like opens up a little bit when you do that. But it's super tight. And then I'll just twist off this plastic insulator here that's on here. And then it'll be just a metal connector there that will be sort of invisible when it gets put down like this on the layout. You won't even see it. So quick tip with the wiring. So I'm using, now remember I'm using the DCS system, so I really want a strong signal. I'm using 14 gauge wire. Through experience from my O-gauge layout, this is the best gauge to use if you want a strong signal on the DCS system. Use 14 gauge. So I'm using 14 gauge, and basically these are lined up with the holes with those little connectors I just pushed in the bottom of the track, and I'm pushing them through now to the bottom of the layout. Now, what I'm going to do is I'm going to go underneath the layout, and I'm going to attach this over to the distribution block that's underneath there before I cut it off here and attach it to the terminal. The reason being, one, save wire, right? Why waste wire just by guessing, right? And then two, I'm trying to create the absolute shortest runs of wire, again, for a strong DCS signal. So two reasons, and you know, copper wire is really expensive. So this is 14 gauge. This is actually pure copper. This is not the aluminum wire with the copper plating on it, which makes a big difference in its signal quality and everything else. So yeah, you want to get 14 gauge, get pure copper wire, and then try to make the absolute shortest runs you can. You're going to have some long runs, and that's okay, but I am saving wire, and I'm creating the shortest runs by doing it this way. And then once I have it attached at the bottom and all sort of routed underneath there, then I will come up here, clip it off, and then attach it to the actual terminal on the bottom of the track. And I'll do that for both of them. I've got red wire, I've got the black wire over here to color code them. And then underneath, when I attach them to the terminal block, I will put a little label on it to tell me where that actually goes. So in this case, it's right in front of the roundhouse where this connection is being made. All right, so underneath the layout, I've got my 3 distribution blocks, which will eventually be connected up to the TIU and everything. But you can see here, here's my first feed that I just did from the roundhouse. Comes up, right? I use these little sort of like loops. You just put a screw through. And I run a lot of stuff like that just to keep it, you know, up closer to the layout top. So if you look here, you can see I mounted a loop there, just comes across, right, and then goes right up inside to the holes that I just did. Use a wire tie through the Meehan cross member here, and it keeps everything sort of nice and neat. So that's the shortest length I can get for this feed, so that's perfect. So now what I'm going to do is I'm going to label this, because this is one of the biggest mistakes I made on the O-gauge layout. The wiring underneath there is a nightmare, and anytime I have to find something, it's tracing it back and it takes me forever. So I bought these little electrical stickers, and they're really nice. They're tough. They won't come loose, and all you do is you can see they're sort of perforated along the line here. So you just write your entry on there, and then you just take it off. You wrap it around the wire, wrap this part around. So the wire would be like basically right going this way. So you take this, you attach it to the back, then you fold that over, and it keeps it nice and secure once it's on. So again, you just fold that long piece over to click the back, and then the piece will be hanging down there. You just flip it up to seal it off all in the back right here. These are sort of made out of a vinyl, so they're not going to tear like paper or something like that, and they're really nice. And so now, anytime I need to find out what terminal number 1 goes to as far as the track feed goes, I know it's the roundhouse entry, and that's it. So I'll do that for all the feeds that are going to come down to these blocks. So I've got an inner loop, an outer loop, and an upper loop feed. Right now on the top, we're just doing the inner and outer loops because that's the first main level, and then we're going to have a second level for the upper loop. So. And that's it. So that's going to be my process for routing wires and marking them, and that way in the future, any troubleshooting I need to do, I will know exactly which wires go where, so it makes it a lot easier. Our finished PowerPoints that are going up to our inner loop. So you can see I've got them all labeled right here, so if I ever have any trouble in the future, I can use those to sort of troubleshoot any electrical problems up on the loop. Each one of these is a section on the loop separated by an insulated pin on the center rail. So if I disconnect one of these right here, say I have a short or something, I'd be able to tell what section it's actually in because everything's labeled and ready to go. This is a lot more work, obviously, but it's so worth it in the end. If you do have a problem, hopefully I won't, but you never know because it is, you know, model trains, so just keep that in mind. But that's kind of the finished product. So right now I've got you know, 1, 2, 3, 5 feeds going up to the inner loop. There I think will be one more. I'm not quite finished with a siding that comes off there, but that'll be pretty much it for the inner loop. And again, this is 14 gauge wire going up to the different sections in the loop. I'll show you that in a second so you can get an idea, but I've learned from experience that having this many drops up to the loop, going by so many track sections, basically what I do is I count them up and I say for each feed, this is how many track sections I'm feeding, and that will give me a 10 signal strength for the DCS signal on that particular track section. So I won't have to worry about anything up there as far as having a problem with signals or recognizing engines or anything like that with the DCS system. So that's why I do it this way. Otherwise, normally for the loop size that I have up there, honestly, I could actually probably use 1 feed, 2 tops. But again, we're just doing this for the DCS signal basically. I have my inner loop sort of finished here. I have my felt road bed underneath the track, right? It's screwed down, and I have my feeds. And just like I did showed you before earlier, I just pushed the spade pins up into the track, and you can't even tell where the feeds are really. Like if I didn't know myself where they were, I probably couldn't see them because they sort of disappear in the track. Every place you see a little piece of blue tape right here, I just put temporarily here so I could tell where the insulated pin was right here. So there's an insulated pin on the center rail only. You don't need one on the outer rails. But this basically is telling me that between here and wherever the next insulated pin is, which is all the way over here somewhere, to the next piece of blue tape, which is right here. That's one section that is going to one of those feeds down there on the distribution block. So I've got 1, 2, 3, 4, 5, 6 pieces of track basically that are being fed by one of those feeds. And so the reason we're isolating the center pin is so when the DCS signal comes through, depending where the train is, if it gets a signal and then the signal's not finished transmitting and it gets to the next section of the track, right, you've got multiple signals happening, and then you can have multiple commands happening that you don't want. So in other words, say you blow the whistle once, but then you'll hear it blowing multiple times because it's getting multiple signals, and that's why we're using the insulating pins. That's the only reason we're doing it. But that is one of the reasons I'm using insulated pins on the center rail only, okay? So if you look at you can see some little pieces of blue tape here and there where I've basically insulated the rails, right? So I'm calculating about 6 pieces or so per section to give me a super strong signal. And then I put an insulated pin, and then I just make sure right in the middle of that section. So you can see I have a piece of blue tape here. There's one right there before the crossover. So about right in the middle of here is where I have the feeds. So the feeds feed right in the middle, both directions to that section. And I found that when I did that on my O-gauge layout downstairs, it worked really well, and I got a 10 signal strength all the way around. So that's what I'm doing here. So I have that section done. I have the section, it sort of goes around here. It's sort of a weird shaped, almost figure 8, right, that comes around here. And then there's another cross over here that goes over into the roundhouse. So I had to put a couple of big pieces on here so I could see where everything was going to get laid out. But basically, right here coming off of this crossover, I have a couple choices. I haven't made up my mind yet. Originally, I was just going to have it come out and sort of squeeze between this section over here and have a trolley running back and forth. But I may actually take it and hook it into the loop right here, just to save real estate up in the front here for things like houses and things. So we'll see. I'm not quite sure. But the main loop here is all screwed down and wired up, ready to go. So our next step is we've got to wire this to the power supply, right, and the TIU. So for our next step, we got to make our switch panel. All right, guys, so if you remember upstairs, I used these rocker switches here, these two-way rocker switches, which basically have 6 terminals on the bottom, to control my power to the tracks, the individual loops. And I'm using these because they go in 2 directions. They lock down in an on direction on the bottom, center is off, up is another on direction. They're separated circuits. And the reason I'm doing that is because I'm allowing myself to either have conventional or command control on the loops. So I basically pick one or the other, you know, it doesn't matter which, it's going to be conventional or command. And then that way then I know I can control different types of trains. So I have a lot of standard gauge trains. Some are conventional, some are PS2s, some are PS3s. I have the Lionel TMCCs. So we got different systems, and we want to be able to run them on any of the loops. So this is the way I'm doing it at my railroad. So I just use these toggle switches, which are really nice. And then what happens is, coming into the toggle switch in the center 2 positions right here, this is what goes out to that power distribution block I was just showing you underneath the layout. And that's what will feed down to all the feeds of the drops that go to the track, okay? Coming in would be these outer sets of pairs, and one is just going to be straight to the coming off the TIU, and another set is going to be off just a power supply from a transformer, variable control transformer like the Z4000 or something. And that way I can control it, you know, whether I want to control it by using the transformer conventionally or using some kind of a TMCC or DCS command control system. Okay, so that's what I'm doing with these switches. So I'm having an extra loop on my layout from what I had upstairs, so now I'm going to need basically a whole set of these switches so that I can do it for each loop. So what I did is I bought just blank plastic box cover. This is for, like, you know, if you had some junction boxes, electrical boxes, you just wanted to cover them up, right? There's no switches or outlets on it. You get these plain covers. And all I'm going to do is drill a hole in these covers and then put the switches through those holes, and then I can use labels on the cover and label them for what they are, right? And then I can take this cover and whatever the dimensions are, just cut a hole in the layout, right? And then just mount this with 4 wood screws directly on the layout. And I have a nice little control panel that's set up. So first thing we have to do is lay out our switches, and we've got 3 loops, and so that means I need 3 switches so that on each loop I can go either conventional or command control, right? And then all we got to do is mount them into this thing, this plate, and then label them. And so what we're going to do is we're going to draw our lines, because I like everything to be really neat. You guys know me by now. So we're going to draw exact lines so we know exactly where the switches are going to be and everything is equal on the plate. And then we're going to drill a hole, and then we're going to mount these inside this plate. All I did, I know I need 3 switches because I have 3 loops. So basically all I did is I put, I centered the line on here, and then I went out equidistance from each side to make them equal apart here. And then I did the same thing. I just split it in half and ran right across. And so these intersections right here are going to be my drill points, right? So now I just got to get the size of the drill hole and then drill these through for the switches. How do you figure out your hole size? Because if you're looking at your switch and there's no instructions, you have no idea what size this is. You can guess, but you can make a mistake, and I don't want to make a mistake. So I have this handy little tool. So it's a drill gauge. So basically, you probably can't see it. Let me put an angle here, but basically every single size drill bit is listed on here, all the different sizes. So all you do is you take your gauge and you take your item, whatever it is, and you just put it through the holes until you find one where it's going to fit. So this is the best one right here, right? It gives me just a little bit of leeway, but it's pretty close to my size here. And then I just look on the actual thing, and it's 30 seconds. So that's the size bit that I want to use on my plate here to drill my hole. So if you don't have one of these gauges, they're super handy. I use them for everything when I'm drilling holes, and I can't tell what size I need based just looking at the item I'm trying to drill the hole for. With this, you can put the item right through it to find out exactly what size you need, and then you're good to go. So just keep that in mind if you ever have trouble finding out what size to use to make sure you don't drill the hole too big. Another quick tip is like when I'm drilling on something like this, which is plastic, which can crack and everything, I usually drill a pilot hole first with like a smaller drill bit. And the reason is because the bigger drill bits, like the 30 seconds, tend to have points on them that aren't as quite as, they don't dig in as deep first, and so sometimes they'll walk around and then your hole will be off or something. So if you drill a little pilot hole first, then you'll, when you get to the bigger drill bit, it'll go right into that pilot hole and you'll be spot on where you want to be. The other thing is, if you're going to use this method like I'm using, if you only have just a couple switches, which is why I'm using just this plate, because I only have 3 switches I need, you want to get a plate that is a little bit flexible. You can see this bends, right? It's not hard plastic. If you get the hard plastic ones, they will tend to break and crack when you're drilling through them if you're not really careful. These flexible ones like this are a much more forgiving and will go cleaner through the plastic. So just keep that in mind if you're going to use this method before you buy your plate. Try to get one that's more the flexible type of plastic. And there's the finished product right there. So I've got 3 switches right here. So I'll put some labels up here for the loops, right? This will be outer, inner, upper for the loop. And then in between the little tabs here, the ons, I'll just put command and conventional. And that's, I'll know which direction they go. What's really nice about these 3-way switches is the center position is the off position, which means you don't actually have to turn off the power supply going into the switch in order to control the trains. I use this a lot downstairs. I found it really helpful because instead of having to, like, you know, hit the transformer handle or the brick or whatever you're trying to do to kill the power, right? I can just, for just one of the loops individually, put it in the center position right here. It turns everything off, and then I can go do what I need to do, whether it's fix a train that derailed or, you know, whatever happened, right? But so, you know, each direction will give me what I'm looking for, but then I can quickly turn off a section with just the center off switch. So I really like these double throw toggle switches. So I got these on Amazon, and you know, they were pretty cheap. Came in the 3-pack, so perfect for what I needed. So that's it. So you can see on the back here we got all our switches with our terminals, right? And all we got to do is get our wires mounted on there, and then we're just going to cut a slot in the control panel area this big, right? Just so these can recess in there, and then just screw this down and we're finished. So, and that's it. Right there, and there's the finished product after you get it all in there. So basically I just cut a hole in the layout, right? These will fit in here. I'll put 4 screws right here to hold it down, and that'll be it. And there's my 3 controls for my 3 loops that I'm gonna have on there. Simple. And then I can put any other switches, like the actual switches, the track switches themselves, little controls here and stuff like that right around this area. And that's pretty much it, guys. So yeah, you can come up with some very simple ways if you don't want to get into a whole bunch of control panel building and you have a very simple layout like my standard gauges. Now, if you have a very, very complex like layout, like an O-gauge layout with lots of routes and everything like that, you might obviously need a bigger, more complex control panel. But for something very simple, this will work. And it's fairly cheap. I only had to buy 3 switches and basically a plate. So our next step to get our loop going here is we've got to get one of these switches powered up and connected to that distribution block you saw underneath the layout. So what we're going to do is we're going to take 2 of the center posts right here. So I think we're going to do like order of the loops that they go on the layout. So we'll do outer, inner, upper, right? So it'll be the center one here. And basically what we're going to do is get 2 connectors and run 2 wires down to our distribution block. Now the MTH distribution blocks have banana plugs on them. So what we're going to do is we're going to use actual banana plugs we got here. So these are actually soldered banana plugs. So we're actually going to solder in our connection right here on this banana plug, and that will plug right into the distribution block directly. We don't have to get any crimp connections or anything like that. So we're going to use these at the other end. And again, because the DCS signal is going through this, we're going to make these as short as possible as far as their length goes. But I just got a set of 10 of these on Amazon. They're 4mm, I think, banana plugs, and they fit right into the TIU and the distribution blocks that MTH makes. I've got it soldered on here. I like the soldered banana plugs better just because it's a solid connection. You can see that little groove right there just gets filled with solder. And that's pretty much it. Don't forget to put your little sleeve on ahead of time before you solder, obviously. And then that just slides up. Now these are a harder plastic, so in order to get these to slide up a little bit better, we're actually just going to use a hair dryer here. We're going to heat that up, and then it'll slide up underneath it. So if you have trouble with getting your insulators on, just get a hair dryer or something to heat it up real quick, and then they'll slide right on. And that's pretty much it. So we're going to create a set of these for each of the distribution blocks that go up to those switches. So basically 3 pairs. And then we'll be able to hook up our switches directly to our distribution blocks, and that'll be step 1. Okay, ran into a small problem with my 90-degree crossovers I'm using. So I did a little test run, and every time the trolley came up to the crossover, it just died. And I couldn't understand what was going on. So I noticed they have this little dial right here that turns with a screwdriver. And I don't know if you can see it, but there's 2 little dots on the corners, and then there's a single dot going on the 4 sides. And I didn't know what this thing was for. I mean, a crossover is just a crossover. I was expecting everything, you know, you power one leg of it and they all get powered. But apparently not. They made a change where you could turn this little dial, and basically, depending which way it was turned, would power only certain directions, the opposite direction, or if you had it in the corners, would power all 4. So I have another switch over here that works just fine, and I couldn't understand what the heck was going on. But when I turned this, it was really loose and sloppy. And the other one was really tight. It actually clicks every time you turn it. So anyway, I took it apart to find out what's going on here. And basically, as you can see right here, a whole bunch of crap fell out from the bottom when I took the bottom off, right? I've got all these little contacts, which were kind of like this, sort of like this, in this direction, like a cross sort of type of thing. And then it had these little tiny rollers, really small, like little tiny rollers in it. But basically what happened is, you can see the little plastic piece right here broke from that dial. So just, I don't know why they had to change an original design that, you know, you never had to do that. I know they were trying to make it fancier and give you more options, but guess what? Not necessary. So anyway, so I was powering one leg of this, and only that one leg was getting power. The other ones were dead. So if you look on the bottom here, they have the 4 center rails here all go to this little disc in the middle here, which sort of has this, you know, tracer on it right here. And it's broken in 4 places, so that, you know, depending where those little rollers are, you're making contact or not making contact. So just FYI, if you get a brand new Lionel, this is the Lionel Corp version, but the MTH ones are the same as the Template Tradition, and you have the little dial right here, that's what that dial is meant for, to change the power depending which rail you're feeding here. But if it's loose, which it shouldn't be, it should be really tight and should snap every time you turn it, kind of click, then it's broken like this one. And now luckily I don't need to use that feature, so all I'm gonna do is tie these all together here. I'm just gonna, because I can't fix this, unfortunately. The little disc is just, you know, busted right here. So what I'm going to do is I'm going to put the disc back in, so visually it looks the same. I'm just going to put a screw and a washer to hold it in underneath here, because there's a little meat left. And then this disc right here, I'm just going to solder a wire across here to make all these connected, so that no matter, because I was feeding the one side basically, and that one side was not feeding the rest of these. So just FYI, if you get a standard gauge modern crossover, they have this extra feature on it, and you want to check it at the store, hopefully, or check it right away. I didn't check it because I had no clue, and of course it's been months since I bought this crossover, so unfortunately I cannot return it at this point, so I have to fix it. But we'll just do a little solder job with some wiring here, and then we'll be back in business. Alright, so there's my final fix there. Just soldered these red ones to make it all electrically consistent across the rails there. Put the little piece back on, so visually it looks the same, and all I did is I put some washers right there, as you can see, and screwed it to fix it. So, and that's it. So I'm actually going to do this to the other one because I have two crossovers and I don't want to have this plastic piece just break from, you know, age or just the trains running over it or something, and then I gotta tear up all the track and everything. So since I had to pull this out anyway, I'm gonna take out the other one and I'm gonna do the same thing and get rid of this switch here that MTH put in these crossovers. Alright, so now we've got our TIU sitting right here on our shelf, which is a nice spot for it. We also have the TMCC base. This is good because it's kind of open and gives a better signal from the remote. But I've marked everything on the TIU for all the different loops at the top, so I know which one is going with which. So as you know, the TIU has four outputs, right? You've got two fixed and two variable. And we have to do something, we have to use one of those for the upper loop because of this situation. This is my control panel here, and you can see that I've got my three loops labeled right here, and then I've got my switches command and conventional. So for the outer and the inner loop, this one's easy. When I put it up in command, it comes out of fixed 1 or fixed 2 out of the TIU. Right, and when I put it down conventional, my power is coming from the Z4000 here, and I've actually labeled the little handles inner and outer so I can always remember which one is which. But when I have it in the down position, it means power is coming from the Z4000 and I have to use the handle. When I put it in the up position, that means power is actually coming from a brick. So these are on bricks on the top portion here. I'm not using the Z4000 for that. And so down below on the bottom shelf here, you can see I've got the bricks down here. I've got them labeled so I know which one is which in case, you know, one pops a circuit breaker or something. But those bricks are coming up to the TIUs into their respective channels. And then I've got the outputs going from here over to the distribution blocks. So I'm using banana plugs that come down to the bricks, and you can see I have the inner and outer ones set up right now, and then there'll be one for the upper one right here, and then the last one right there is going to be the upper conventionals, because remember, I don't have two handles up here, or excuse me, three handles, right? I've only got two, and unfortunately the Z4000 is not like the Lionel transformers where you have four channels, right? I've only got two that I can control manually. So I've got to be able to control the upper loop somehow manually, and I'm going to do that with the last output on the TIU that's a variable, and then it would be controlled with the actual remote, right? So if you remember that from upstairs, basically the remote is able to control the output when it's on a variable. So by default it's 0 volts when you turn it on, and then you use the thumb wheel to turn up the voltage, just like you would a handle on the Z4000. So it kind of works the same way. So really what I'm doing is the two main loops on the main level are going to be controlled by the transformer conventionally. If I need conventional on the upper loop, I'm going to use that variable. Now remember, one of these outputs is also variable here, and we're going to change that to a fixed output, so then it would act just like the other two fixed outputs with a brick coming into it to power it, and then going out to the distribution block as a solid, you know, fixed 18 volts. Finished distribution blocks. You can see I have my banana plugs here, which, you know, unplug and plug really easily. Those are the ones I soldered on. Those are, you know, going over to my little control panel, right? And then I have all my feeds coming in here that go up to the tracks. But the signal that's coming in here from the TIU is being controlled by that switch. So it's either coming through the TIU, solid 18 volts, or it's coming through the Z4000 transformer handle and giving a variable voltage. And that's what I'm using those little toggles for. So this is all set up for the, I've got the inner loop done, the outer loop, you can see everything's labeled. I also have a TMCC signal, if you can see right here, okay, going to the outer rail on both of these loops. And I actually ran 3 separate TMCC wires up to the TMCC base. So instead of using one wire and sort of splitting it, I ran 3 separate wires up to the TMCC base, and they both go over there. Are my bricks underneath here. I've got 2 bricks right now. There's going to be a third one for the upper loop, which I haven't gotten yet, but these obviously go into the inputs to the TIU. This is a 75 watt brick that's going into the external power supply for the TIU. That way the TIU never goes down. It's always up. Even if I have a short on one of the loops and I have to reset one of these bricks, the TIU is still up and running, and I don't have to wait for it to reboot or anything like that. So, and like if I had 3 loops running, the other 2 loops would still keep going, so it doesn't disturb everything. I like having the external power supply on the TIU. It's totally optional, not necessary, but I do use it. So there's going to be a 4th brick down here, and that one is for the upper loop. And you can see up here, I've got my outputs. 3 of those are command outputs going for each of the loops, and then the last one is going to be the variable that I'm going to use for conventional on the upper loop. And on the other side, of course, I have the inputs coming in from these bricks. And that's pretty much it for that. I do have a power strip up here that's powering all the bricks. The Z4000 and the TMCC base is all on that one strip, which goes over to the switch here, right? One of the main power switches. And I'll label that switch. So that switch is really everything that has to do with track and signal. And then the other switch is going to be for powering accessories and other stuff on the layout. So that's what I'm using those 2 main power switches for. And I'm going to actually hook in some kind of light or something that tells me that the power is on, because the problem is on those toggle switches I use up top, if I turn them to the center position off, everything looks like it's off, but actually, because these 2 main switches are on, the bricks are still being powered and everything, right? So we want to make sure everything gets turned off. So we're going to have sort of an indicator light up top that tells me that there's still power to parts of the layout. And I think that's about it for the whole wiring setup at this point. So as you can see, that's pretty much my track plan for the main level. I've got an outer loop that has a siding on it where I can park trains and things like that. And then I've got this inner loop, which is sort of this kind of odd shaped figure 8 that's sort of at an angle, goes around the roundhouse there. And then I put the 3 biggest buildings on the layout so I could make sure that I'd have space for them. That's the main thing. These are the largest standard gauge buildings made. There's none that are bigger than this. The biggest is the 444 roundhouse. And then of course you got the 840 power station, and then you got the illuminated terrace back there. So I'm just using them temporarily. That's not their final location for the power station or the terrace, but I'm just using them to make sure things clear, and then also we'll be using them once we get the upper level started. So that is the 2 main loops right now. Everything's completed. So let's see if it actually works. We're ready to test this out, see if everything actually works. So first thing we're going to do is obviously we're going to power on our bricks and TIU and everything. So we're going to hit the power switch there. We're going to turn on our Z4000 so that we can run conventional control, and then we're going to actually power on our remote here before we try to power up any engines. So what I've got here on the inner loop, I've got this little sort of 384 right here. This is a conventional locomotive, and it actually has an air whistle in it, which is kind of old school, kind of cool. So we're going to run that on the inner loop, and then over here we've got 9E here. This is a DCS, and it's the Steven Gerrard passenger set, 2-tone green. So we're going to run this one on the outer loop in command. So how are we going to do this? All right, so we got our switches here, right? So we know in the inner loop we're doing conventional, so that means this has to come down, right? And that means that it's going to be controlled by one of the transformer handles. I actually put a little label just so I could tell which one was which. You know, you forget after a while, right? So I know this handles the outer loop over here. That's the one I want to use. And then on the, the inner loop, right? Because that's the one I have the conventional train on. So I want to use the right handle here. That's the one I want to use. And then on the outer loop, I'm using the 9E, which is a DCS. So that one we're going to switch up to command. And you can see it just lit up right here, right? Okay, so I think we're ready to go. So let's first start on the outer loop right here. We're going to start up our engine. And then we're going to hit the whistle button, see if it works. Okay, that's a good sign. Hit the direction button, so we're going forward there. And then we're just going to give it a little, we're just going to go quick speed of 10 right here. And hit the thumb wheel. And we're off. Alright, so we got the outer loop running. Alright, so now let's see if we can do the inner loop. So all we're going to do now is use our transformer handle right here and give it a little juice. We got some power there. We're in neutral right now, so we're going to hit the direction button. Backwards, neutral, forward. And we got power. So far so good. Hit the whistle. I love those old air whistles on the, kind of like the post-war trains and stuff. So obviously on the conventional I can hit the direction button, stop it, and then back it up, right? Now I'm doing everything on the Z4000 for that one. And then I hit the neutral, forward. And on the 9E, I can speed that one up a little bit. Now I don't have the switch controllers in place yet, so I can't switch it, but I have to go to the switch to manually route it to the other side, but so far, so good, though.
Alright, next station on track 2, train number 170, the Patriot. Have a nice day. Thank you.
Alright, so that's it. So for the conventional, I just turned off the handle here. For the command right here, if I wanted to make sure there was no more power, you can see the passenger cars are lighted right here. If I take my little switch on my panel, I just put it in the off position. Now the entire outer loop is without power. And that's pretty much it. So really easy to control from these toggle switches without having to power down the entire layout or the bricks or the TIU. So I really like these a lot. And then again, one thing you do have to remember, and I always do this every time I'm finished, is I always put them back to the off position, because if you put a command engine or conventional on one of the tracks, depending where this is set, you're going to have full 18 volts, right? So if let's say I was running command on the inner loop right here, this thing would go right immediately to 18 volts right away if I put a conventional on there. So got to be a little bit careful. So I usually set these to off once I'm finished with my running layout, whatever I'm doing. Right, and then on the switches, if you are using the Lionel MTH switches, they do have a little switch here called track or auxiliary. So if you use the 2 posts over here, you can power these from a separate auxiliary power supply, which I guess you could do if you wanted to. I just have them set to track because they don't need much power to flip when they're running. And if you have a train running at all in command mode, it's going to be full 18. And if you have it running in conventional, if the train is moving at all, you're going to have enough power to flip these switches. And since I only have 3 of these total on the layout, it's not worth wiring auxiliary power on these. There's no reason for it. So I just have them all set to track. You can see they got the cool little switch lanterns here all lit up in red and green. So really neat. I really like them. They're kind of nice. And the trains actually go through them pretty smooth if you make sure that they're perfectly level, because even though they look like they're made out of heavy steel and everything, they actually can bend a little bit as you're screwing things down on the front legs or the back here, and you can actually make them like a little hump in them or a little dip in them depending. So as long as you make sure they're perfectly level going across here, when the trains come through, they won't jump through the switch because everything is kind of perfectly level through the switch. So I usually take a little straight edge and I go through the whole thing right across it just to make sure everything is perfectly level, there's no gaps, and if there are, then I adjust it to make sure that it's flat. So little tip on that, if you think right out of the box you can just throw them on a layout and they'll be perfect, maybe not. You might want to check it first. And if you do, your trains are going to run through these switches much smoother. If your trains are going through these switches and they're sort of bouncing through, then it's probably not perfectly flat, and you want to just check it. Alright guys, that's going to be it for today's video. I hope you enjoyed it. I feel like we're back to where we were when we were upstairs at the layout. So we got up to this point now where we got track, we got power, right? We can run trains. And the first main level is done. Now, our next step is going to be the elevated level, or the upper level, which I didn't do upstairs. And I got some cool ideas for that. We're waiting for some materials to come in, but again, it's going to look very toy-like, and I think it's going to be really neat when it's finished. Very unique. Something that you probably haven't seen before. So, that's going to be our next step. In the meantime, we can do a couple small things for some wiring and things like that. And yeah, make sure you come back and check out the next episode, because I think that one is going to be really neat. Now, we can't put anything on the layout yet as far as buildings and lights and stuff until we get this upper elevated level done, so we know exactly where everything's going to be, because obviously it's going to need supports and things like that go around the layout. So, but yeah, so as always, I hope you enjoyed this video. Make sure you subscribe, hit that like button, put your comments down below, and I will see you guys next time. Peace, guys.